Hey everyone, in this video we're going to talk about the breathing circuits, and we're going to discuss the 4 different types of breathing circuits and how you can differentiate them when you're posed with a question or if you're shown a circuit and you want to try and figure out what kind of circuit this is. So the 4 different types are semi-open, open, semi-closed and closed. They can be further broken down into your semi-open and open circuits, which is when the patient doesn't rebreathe any of their expired gas, and the semi-closed and closed circuits, which is when the patient does rebreathe their expired gas. We can then differentiate our breathing circuits even further when we talk about our semi-open versus open circuits, as a semi-open circuit is when the expired gas goes through a one-way valve, which ensures unidirectional flow away from the patient, while our open circuits is when the patient expires directly into the atmosphere. So technically with the open circuit, if the patient is breathing really quickly and not expiring all their gas into the atmosphere, they could technically rebreathe their gas. And the importance of this is that we're trying to get CO2 away from the patient so that we're not rebreathing our CO2. So realistically, we're trying to figure out how we're getting CO2 out of the system to stop rebreathing. Then when we talk about our closed system, so our semi-closed and closed system, the question you're asking again is, how is CO2 removed? And with a semi-closed system, CO2 is removed through a valve or directly into the atmosphere, but it's reliant on fresh gas flow, meaning that as the patient breathes, the amount that they're breathing needs to be less than the fresh gas flow for all the expired air to be completely removed from the system. And that expired air, as I mentioned, will be removed either through a valve or directly into the atmosphere. The question you're probably thinking now is, what's the difference between a semi-closed system and an open system then? And the difference is that in an open system, you're expiring directly out into the atmosphere. In a semi-closed system, you're expiring into tubing or some kind of reservoir bag. So you need increased fresh gas flow to make sure that you're not rebreathing all your CO2. But if it's less than what your minute ventilation is, or your minute ventilation is less than your fresh gas flow, then you will expect some rebreathing of your expired air. For a closed system, it's a little bit easier to differentiate because in a closed system, all your expired air is rebreathed. So you rely on removing CO2 with some sort of CO2 absorber such as soda lime. When it comes to where you may see these different breathing circuits being used, you're more likely to see open systems in ICU and portable ventilators, on the wards for nasal prongs, non-rebreathers and Hudson masks, and ambu self-inflating bags as well. But the key thing here that can also help you differentiate is that when a volatile anaesthetic is being used and you're worried about the anaesthetic leaking into the atmosphere and affecting staff around the patient, you're more likely to use a closed system over an open system, because an open system by definition means that they're exhaling into the atmosphere, which means that you can have leaks with your volatile gases. So that's another way you can think about differentiating them. And then for closed systems, for the same reasons, they're usually used in anesthetic machines because the volatile anesthetic is kept in this closed loop, which means that you can use less volatile and recirculate it around, and you can also protect staff from the volatile anesthetic as well. For your semi-closed systems, usually people talk about Mapleson circuits, which in a way, depending on how they're used, may leak into the atmosphere, but it really depends on the type of Mapleson that you use. So if we were then to break this down to a flow chart to try and figure out what breathing circuit is being used, we could ask ourselves essentially 2 questions. The first one could be, does the patient rebreathe expired gas? And the answers can either be yes or no. And if the answer is yes, it's a type of closed system, so it's either semi or fully closed. And if the answer is no, it's a type of open system, so it's either semi-open or open. If your response was yes to the first question, so it's a type of closed system, the next question you would ask is, do they rebreathe all their expired gas? And it can either be yes or no. And if the answer is yes, it's a closed system, which is reliant on CO2 absorbers. And if the answer is no, it's a semi-closed system, which is reliant on increased fresh gas flow to remove CO2. For our open systems, if your answer was no to the question, does the patient rebreathe expired gas? Then the next question you would ask is, do they expire through a one-way valve? And the options can either be yes or no. And if the answer is yes, then it's a semi-open system. And if the answer is no, then it's an open system. And for your semi-open systems, this would be things like your bag valve mask ventilation, such as with an ambu bag or a non-rebreather mask. And for your open systems, this would be nasal prongs or Hudson mask. So lastly, if we were just to draw this into a table and then have some examples, we would draw a table that's got 5 columns and 4 rows. And you'd label your columns classes, defining characteristics, the question of do they rebreathe their own expired gas, your fresh gas flow, and then examples. So for our classes, you can have your open and semi-open, and your closed and semi-closed. For defining characteristics, you can say for open that CO2 is vented to atmosphere, while semi-open CO2 is vented via a one-way valve. When you ask the question, does the patient rebreathe their expired gas? When it's an open or semi-open system, the answer is no, they shouldn't be rebreathing their own gas. And then fresh gas flow for each. For open systems and for semi-open, it's intermittent. And then examples of open systems would be nasal prongs, Hudson's masks, a Hunsaker tube, which is a type of tube that you can jet air into the lungs past an obstruction. And then there's the Schimmel-Busch mask, which is a mask we don't use now, but it's essentially a piece of cloth sitting over a mask, which anaesthetists used to just drop ether onto, and the patient would breathe the ether gases in and then exhale directly into the atmosphere. Then examples of semi-open systems would be your self-inflating ambu bag and your non-rebreather mask. And both of these have one-way valves on them. So if you ever look at an ambu bag, it usually has a one-way valve on the opposite side to the actual self-inflating bag. And then non-rebreather masks, if you look at where the nose sits, there's usually these little plastic tabs that sit over some expiratory ports. So when the patient breathes out, air will blow past the little plastic tabs. And when they try to breathe in, the plastic tabs will occlude inspiration and they'll breathe in directly from the reservoir bag of oxygen. But again, in the semi-open system with, say, for example, a non-rebreather, if the patient's breathing really heavily in big tidal volumes and they're emptying that reservoir bag, technically they will then start to rebreathe their own gases as well. Or if they're breathing in a way where they're not actually able to push air past into the, with enough force to get it past the one-way valve, they potentially will also rebreathe. For our closed and semi-closed circuits, we talk about for closed, the defining feature would be CO2 is removed by a CO2 absorber, while with semi-closed, CO2 is removed via fresh gas flow, which washes the circuit of the CO2. So then the question is the patient rebreathing their own gases? And the answer for closed and semi-closed is yes. But for semi-closed, it gets a bit more nuanced, as it's kinda a yes, because if fresh gas flow is greater than minute ventilation, then no rebreathing, or at least decreased rebreathing, should occur. When it comes to fresh gas flow, for closed and semi-closed, they're reliant on pressurized, constant fresh gas flow, and it's not intermittent like your open and semi-open. And then examples of closed circuits would be your circle circuit with fresh gas flow matching gas uptake. And your examples for semi-closed would be circle circuits with an APL valve that's open. So the patient, when they breathe out, once the pressure reaches a certain limit, the APL valve will expire more pressure or more gas into the atmosphere. And then the other example is Mapleson circuits, and Mapleson circuits come from A to F. And then finally, just to reiterate the points of how we differentiate them, the first question I always ask when I see a different circuit and I want to try and differentiate between open and closed is, should the patient be rebreathing, or is the patient rebreathing their own expired gas? And if the answer is no, it's open or semi-open. If the answer is yes, then it's closed or semi-closed. The next question I ask is, well, how are they getting rid of the CO2? Because the point of breathing circuits is that it will deliver oxygen and breaths to us and then remove CO2, which is a waste product. And for open and semi-open, for open circuits, they will breathe directly into the atmosphere. And for semi-open, they'll breathe through a one-way valve. And then for closed, they're reliant on CO2 absorbers. And then for semi-closed, they're reliant on fresh gas flow that washes the circuit and then allows the breath to exit through an APL valve or into the atmosphere. And then lastly, you can look at the circuit and look at how air is being delivered to the patient. And if there's some sort of pressurized constant flow, it's most likely a closed or semi-closed circuit. So these are my tips and tricks and ways that I remember my different breathing circuits. If you have a different way of remembering, feel free to leave it in the comments. I'm always interested to see how other people remember this.